class of core.
Wait, there's only 8 people in here?
Yeah.
Okay.
All right, so I'll do that.
Yes, but this is McDonald. Matt McDonald.
He's part of the,
I believe so.
okay.
Yeah, Ed does the second half of the course.
Got it.
Ed said he'll be here March 17th, I think he said. This guy does the R part and Ed does Python.
Okay, what did I just walk into?
Yeah, this is all mathematical modeling.
I mean, I model at my firm, but do I need to know R and Python before we can even go anywhere?
In this class is mostly R and Python. And I heard MATLAB too, but in the syllabus it says Python and R.
Okay.
I have to like adjust the lights so that the lights are dimmer in front. That will help you guys see this, right? The screen. Is that better? It's better, right?
Yeah.
Professor,
Yeah.
I think I have a problem.
What's that?
So, pick this programming class to, you know, bolster my programming and modeling skills. I didn't know we needed R to do this class.
Okay.
I don't know R.
Oh, you're gonna be in good shape. I don't know, well, that's the first thing I'll ask folks. Well, actually, I do have some admin stuff to do, but we don't,
I'm with you, I'm with you. I just,
yeah, we'll talk about R, and Python, because half the class is presented in Python. And we kind of merged not merge the two, but either one is acceptable for the work. But I'll just be, because we think it's valuable to expose students to both R and Python, we do part of the class in R as well. So the concepts do sort of apply to both languages. So do you have Python experience?
I mean, I'm enough to be dangerous, but
Okay.
I am a very rudimentary Python user.
Okay, that's perfect.
Okay,
We
so,
actually do quite a bit of hand holding early on.
so if I'm an invalid, I can get through this.
You'll be in good shape.
Perfect.
I had a request to record the class, and I've never done that effectively, so let's see if I can get that working.
How do you do financial modeling without any languages?
Well, there's a whole bunch of stuff that we do. We have, I am the refiner. I have a lot of little admins that do a lot of the programming. And
Okay.
that's where we are. I've progressed enough in my career that I don't have to do that. A lot of my stuff was in good old Excel, where I did a lot of my
Okay.
financial modeling.
Okay. Okay.
This was to help me advance in these stages where I can actually start rebuilding kids' models that are really rough around their edge.
Gotcha.
Okay, so I think I'm recording the content, which is good, which is what I wanted. So, hello, welcome to Finance 5352, Financial Programming and Modeling. I'm Matt McDonald, Professor McDonald. This is sort of my side gig. In fact, I used to work with Professor Hayes, who some of you must have know Professor Hayes.
Yeah.
I think Cliff, you do. He introduced me to you once.
Yep.
And so we used to work together. So I'll kind of get into that in a bit here. So what I like to do is first kind of talk about like who I am, where I'm coming from. So like I said, I used to work with Professor Hayes. We both worked at GE Capital for a few years, and we were both working on kind of like a modeling context, but like in big financial companies, there's a role called model risk management. And so we were both in the model risk management department. So we weren't so much building the models as much as performing oversight, making sure that the models were doing what they were supposed to do. It's a little bit of a dog and pony show for regulators, right? So that's kind of the main audience of that work.
So
But-
like stress testing them or breaking them, that's what you guys do?
Well, it's more about like, well, it's like a very sort of oversight control role. So you start with policies and procedures, and then you see to make sure that people are following the policies and procedures. And that's kind of where we were. But prior to that, this is kind of historically going back. So I started my career as an actuary, and then I worked for a little while as a software engineer for Priceline. And then I went back to school a couple times. They used to have a thing here at UConn called Edge Lab that was a collaborative engagement with General Electric. So I'm a graduate of University of Connecticut. I got my MBA here in Stanford. After there, I went to IBM, started doing more credit risk modeling. I was working in their global financing division, building more credit scoring models. And then that's been sort of my career since then, right? So credit scoring kind of picked up at IBM. At GE Capital, I was more regulatory facing, but still in the credit space, we were looking at both credit models to evaluate credit, like credit scoring type models, but also looking at stress testing models. So like stress testing the portfolio, there are a bunch of different types of asset classes there that we were looking at. And now I work at Kroll Bond Rating Agency, so that's sort of, you've heard of the big ones, right? Moody's, S&P,
Standard & Poor's.
Fitch. right? And we're kind of like a challenger in the market, right? So we're sort of a smaller operation, but we're growing, right? So at Kroll Moderating Agency, I've done both the model oversight, model risk management job, and now I build the models for the credit rating analysts. So I manage a team of data scientists and econometricians and financial modelers, and we build models for credit analysts to use in their work. And those models are kind of, some of them are like more credit scoring type models where we're trying to estimate like a probability of default. But a lot of them are more like stress testing models where we're contemplating some sort of scenario, and we are trying to sort of say like under that scenario, what's a plausible outcome for different types of pools of assets, generally speaking. So like residential mortgages, commercial mortgages, and other sort of pools of assets that generate cash that somebody is trying to put a bond out. Right? So a lot of structured credit type stuff.
You're talking like tail risk, Monte Carlo, all those kind of things?
Well, we do Monte Carlo. Some of our models are, we use a Monte Carlo stress testing model for some of our structured credit stuff. And others are sort of more in line with the types of models that we'll be talking about, which are like statistical models that would say like, going to estimate a probability of default. And some of the things I've chosen that is going to depend on are factors in my scenario. So if those get bad, then my probability of default goes higher.
So I'm hoping I'm in the right class because I know all of that stuff you've read, and I've done work on that stuff. This is actually going to be, even potatoes and bones on something that's going to build something to do that.
Yeah.
What this class is.
Yeah, so what I do here in this class is, and we'll look at the syllabus a little bit. So we kind of break the class into halves, and then my half is kind of broken into halves again, right? So the first half of my class is a little bit of I would say introduction to R.
Okay.
Yeah, we'll do a little bit of an introduction to the R programming language. And we'll really focus on what are the functions and packages available to really focus more on like the data side of the equation. How do I handle data? What do I want to do with my data? Leading up to the modeling part, where we'll sort of talk about a lot of the fundamental ideas that happen when you are trying to think about a statistical model. And then laying that foundation, and I pretty much get us into some sort of more linear type models. So we'll do linear regression, and we'll do logistic regression for classification. And then when Professor Hayes comes, like there's a bit of a shifting, so he'll be looking mostly at Python. I do believe that a lot of the concepts that we talk about are very much in play in Python. It's just a different syntax. And having exposure to both is good, I think. But he'll be focusing more on like the more advanced algorithms that are available, tree-based algorithms and other types of more deep learning type stuff. So I think it complements itself well. But so my educational background is I'm kind of a math guy. I'm a math undergrad. I don't hold a PhD. Professor Hayes does, so he's got me on that one. But I am an alumnus of this institution, and specifically in Stanford. I did all of my studying here. And I did follow it up with a deeper dive into statistics with a master's in statistics. So that's who I am. And my career path has been somewhat circuitous, like it hasn't been focused always on the same stuff. But there's a theme here, right? So like actuarial into IT and software development, both of these things kind of laid the foundation for me to be able to kind of do what I do today, which is that credit modeling. And even though right now my current role is not directly about model risk management, it always is, right? So in model risk management, they kind of talk about like, there are 3 lines of defense. So I'm in the first line, I'm the one building the model. And I need to be thinking about like, how do we build models that are gonna work, not break in the future, and what do we gotta do around them to make sure that they don't cause a problem down the line. So then that second line is the person who's challenging me to make sure that I'm doing it. Then the third line would be like audit staff who come in and make sure that everyone's doing what they're supposed to be doing. So, any questions there? Okay, so I did want to just share the syllabus with everyone. And it's kind of frustrating because they didn't give neither Ed nor I access to Husky CT till today, so I wasn't able to really share that with the class.
It's up there, Husky CT.
It's up there,
yeah.
so I put it up there today, so it's kind of like just in time access to that. But there's a couple things I wanted to sort of highlight. You can read this sort of at your convenience. Let's see here. Okay, there we go. So the one thing I wanted to highlight here is AI usage, right? So Ed and I have talked, and we're very much in favor of everybody using as much AI as they want. The only caveat is that if you do use it, we would like transparency. So just tell us how you used it, whether you used it, how it came into play. But there's no judgment or penalty for using it extensively. I mean, I would say that like in the past year, even less than year, my job has changed quite a bit. We're using it quite a bit at our job. And for this domain, for modeling and working with data and coding, it's very, 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 it's very helpful, very helpful. So like I said, no judgment, it's not gonna impact your grade if you use it extensively. And the only thing we request is, include a statement of how you used it, whether they were used, and if so, how. Any questions there? I think that, I really do believe like this is a skill that you're gonna have to have in the workplace, so you might as well use it. And then one thing that Professor Hayes and I are doing a little bit differently this time is that we have a common book that we're teaching to. It used to be that like I had my stuff and he had his stuff, but now we are using a book, Introduction to Statistical Learning, by all these authors. Lots of times I think of it as Hasty and Tib Shirgani, but it's Gareth James and Daniela Winton as well. And this is a really solid, well-known book that I think does a really nice job. They had an earlier version that was very, very technical, and this one's a little bit less technical and more approachable. So we'll be using that. That'll be really good. And the cool part is that Professor Hayes, when he comes in, he'll be leveraging that one as well. So there will be a little bit more continuity in the class. I do, as I said, like I teach a bit of, before we really get into the statistical modeling stuff, I do think it's really important to know how to work with data in a programming language. So we're going to be using the R programming language. So the book R for Data Science by these two authors, Hadley Wickham and Garrett Groldman. So Hadley Wickham is if you've used R, you probably have heard of RStudio, and we'll be talking a little bit about RStudio. So there used to be a company called RStudio, and they rebranded, now they're called Posit. But this guy, Hadley Wickham, is the chief data scientist for Posit, the RStudio company. And he's written a lot of the packages. He actually has written a lot of very, very foundational packages that we'll be using. So these are packages that are very good and popular for working with data and also visualizing data. So we'll be talking about that a lot. So those books are will be referenced quite extensively. And then a bit of a supporting book by a guy named Max Kuhn, who also works at Composite, formerly RStudio, is called Future Engineering and Selection. So the good news is all these books are free, so if you want to buy them, you can. The links are there, but they're all freely available online, PDF versions. So I think that's pretty good. And then Professor Hayes has his books listed here, but as I said, he will be leveraging highly the, I call it ISLR, Introduction to Statistical Learning. And then, just real quick, I have a little bit of info here about installing R. There's a couple links if you need help installing it, or you could reach out to me on email, I'll respond, but it's pretty straightforward. We'll be using R. A lot of people get confused R and RStudio. They're kind of, if you're using RStudio, it feels like one thing. There are actually two things. So R is like the programming language, and you know, you download an executable that can execute R, and RStudio is the IDE, Integrated Development Environment, that you can write the code and work with it. The other thing is I do have a GitHub link, so all of my course materials, I will push to that GitHub link throughout the semester. So any slides, I write all my slides in a programming language called Quarto, but it renders as HTML and PDF. So they'll have the HTML, the PDF, and then the code that generated those slides. And then if we have like a little programming, tonight we'll be doing like a brief session doing a little bit of interactive programming for me to show you all the language. Those files will also be up there. And I think I also put them in Husky CT, so I'm trying to make this very much freely available for everyone. The GitHub is, we use, I don't know, has anybody heard of the word Git or familiar with it at all? So it's like software developers use it, right? It's like how they manage their work. It's a tool that's really good at, it kind of like keeps, it's the source code of your code, so it's a way to share code amongst many people. And it also does a very solid job of tracking changes that happen as you're doing them. So you could like do some work and then decide you don't want that to happen, and then you could roll it back really easy using this language called Git. So I use it a lot at work, but it also turned out to be pretty useful for this type of environment where I'm working on stuff and then I just send it out. So that's where it goes. You can get the link there. So it might require you to sign up for a login to GitHub, but that's no big deal. You just have to remember a new password. And then here are the lessons. The one thing I will say is like we're still, well, I'm still working on integrating this new book into the coursework. So I'm going to point your attention to specific assignment details may be adjusted as the semester progresses. So I haven't put any assignments in here yet for that second book, Introduction to Statistical Learning with R. If I do put any assignments in there, I'll make sure you all know about it. I'm not a huge I'm not like an academic, like I have a day job. So like, I'm not a huge stickler for assignments, so don't worry too much about that stuff. I just wanted to let you know that like, there may be a couple of assignments added, and if I see something that I think is particularly reinforcing of what we're talking about, I'll put it in there. But you can see here that like, so tonight we'll be doing an introduction to R, and we'll be talking about also in RStudio, but we'll be talking a little bit more generally about the overall data science workflow and doing a little bit of interactive examples. And then the next few lessons are really focused on like continuing on the analytical workflow and talking about working with data in a programming language and visualization, and then exploratory data analysis, data wrangling. And then for the second half of part one, which is my sort of segment, that's when we start getting a little more into the modeling stuff. right? So we'll be talking about linear regression, resampling methods, multiple regression, and then doing a closing with classification. And then that is kind of, the classification is the foundation of, there's a project that we'll be working on, which is a credit scoring project. And then Professor Hayes comes in with his fancy stuff, all kinds of decision trees and machine learning and neural networks and other very much cooler stuff than what I do.
All of this stuff is what I remember when studying for my charter, for my CFA, and all of this stuff, but it was all theoretical.
Yeah.
Nothing
We'll
was
be
in
getting a
practice.
little, we'll be getting hands-on. We'll be
Okay.
getting hands-on. So that's gonna be pretty good. Okay, so that's the syllabus. Any questions there? You can email me or, get to that. But getting back to here. Okay. So here's sort of a core sort of statement for this class, right? Like, you know, I do modeling, but I do modeling in a financial context. And like, you know, it's a lot different than like modeling that happens in like biostatistics or pharmaceuticals or these types of places. There's like a lot more, they have a lot more, a lot less wiggle room, right? Like here in finance, I would say that like we're not really intent on finding the right answer. Lots of times we're trying to find like the good enough answer, especially in the context of like how I use these models or how the people who I work with use the models. Like think about a stress testing model, right? Like, okay, I need to imagine I have a portfolio of assets. I need to sort of contemplate or imagine what would happen if we did the great financial crisis again to these mortgages or these commercial mortgages or whatever it is. I'm not really that concerned about accuracy, right? Because I could.
It's like saying you're dealing precision, not accuracy. That's what my PMs have always told me.
Yeah.
Dealing precision.
Yeah, well, even precision, but like, there's no way to understand if what comes out of my model is either accurate or precise, because these are like, I can't ever go back and test it. Like these mortgages that I'm looking at today did not go through the financial crisis. So at the end of the day, now this might be very specific to like my domain, but like a lot of the questions I ask, like you want it to be accurate, you want it to be precise, but there's really no way to ever evaluate that, right? So there's always going to be a level of kind of user evaluation or judgment that comes into play. To be like, is this sufficiently stressful, right? Like, and is it plausible? Like, I could just say that every mortgage defaults and I lose all my money, right? But that's probably not plausible, right? Like, that would be, right? So you kind of need to do that. So like, the other thing is like, there's always going to be, there's a tremendous amount of noise and uncertainty. We can't measure every single, you know, risk driver out there in the world, right? So we're limited to a smaller set of that, and that does bring in quite a bit of noise and uncertainty. And then when we talk about trade-offs, a lot of times the trade-off is like, I have a limited set of resources, I have a limited amount of money, and I need to kind of get this thing done. So like, lots of times the good enough answer wins out, right? So it's not always about the best answer, it's about the good enough, most right answer that I can get to. So this course is not about like learning every algorithm in and out. Although Professor Hayes is going to expose you all to like a lot of algorithms, right? So my half is we're more dealing with foundational, fundamental type ideas and dipping our toe into some of the simpler, sort of very mainstream algorithms that everybody's heard about. Linear regression, people probably have heard about. hopefully logistic regression is something that maybe has a little bit of familiarity. We'll get kind of deep into that. But it's an applied statistical learning for finance. We'll be talking about regression and classification. We'll be talking a lot about it, once I build a model, how do I interpret that model? And how do I determine whether that model is good or bad? How do I look at this model in the context of another model and compare the two? How do I think about that, right? And understanding like trade-offs that exist. I mean, the trade-off that I mentioned, you have a limited amount of money, but like in the modeling context, there are definitely trade-offs, right? So accuracy versus robustness, we'll talk a lot about. But this next one is very important, and this one comes up a lot in my line of work. Simplicity versus flexibility, right? So the idea is like, I could build a complete black box, and I think like working with ChatGPT, it seems like a black box to me. I don't know how it does what it does, but it seems to work, right? Where I work, because lots of times I'm handing these models off to other people, a simpler model is better because I can explain to them how to explain to somebody else what's going on. And so keeping it simple is sometimes you will sacrifice, when we talk about flexibility, that is talking about like accuracy and how well you sort of predict this thing, predict a thing. Lots of times explainability is something that is very important as well. So like, it's not always about like, let's use like the coolest and the newest and the flashiest algorithm. Sometimes it's like linear regression can get you 80% of the way there, and I really only need to be 80% of the way there. And I've also bought myself an opportunity that I can explain to somebody, how to explain to somebody else how this thing is, how I'm getting this answer.
Aren't there statistical guardrails that you could use, like your R's, R squares, and all that kind of stuff, so to limit getting too crazy with all the complexity?
Well, yeah. I mean, we'll talk about it, and we'll have some illustrations on it. But like, you know, you could have a model that does. I mean, think about a line. Let's say I have a line. I'm going to draw on the board here. So anybody who's seeing a recording of this will not be able to see this. But like, let's say and we'll sort of see this later on, but let's say I have like a true function that kind of looks like that. So this is like truth, this is how the world works. And I'm observing, right, this is whatever my y is, and this is whatever my x is. And I'm observing noisy data that kind of lives around this line, right? Well, in a linear regression, I might draw a line like that, right? That is my estimate of this data. Because like this wavy thing, I can't observe it. I don't know what it is. I'm trying to estimate it. It's not something that I understand. I can really actually get to. It's ephemeral. I can't put my hands on it. So this line does a pretty good job of fitting these points, but a more flexible approach might be able to estimate something that kind of is a little bit wavier, right? So your choice of algorithm doesn't matter, but a lot of times that straight line, which is not going to be it's going to be less accurate. It's going to do a worse job of predicting those points, but it might do a good enough job. And also, because this thing can be written as a function of y equals a parameter times x, right, plus some error. Like I could explain to a junior analyst, like, my price of this thing is equal to 50 times whatever x is, whatever I chose. Like that linear function is really easy to understand. Like much easier to understand and convey than like a neural network with multiple layers and all kinds of crazy stuff going on, right? So like I'll call it simplicity or interpretability, sometimes is a feature that you're actually willing to sacrifice accuracy for it, because I can easily explain how this little stuff works.
Gotcha.
Okay, so this is a little bit of a strange course in that we don't actually choose a language. We kind of do both. We're trying to do both. So part one uses R. So R is a really nice programming language for statistics and modeling. And Python is also a really good language for statistics and modeling. I would say that R, because it's built specifically to do statistics and modeling and data analysis, it's probably a little bit better than Python. That's a controversial take, but I'll say it anyway. So the thing about Python, it's also very good at all those things, and it's also very good at basically anything else you would want to do. So like I've heard it said that like you can pick a language. R is the best language for data analysis and model building, or like Ruby is the best for web servers, or I don't know really, but you can pick a language and say like this is the best at this. Python is the second best language at everything. It's a very powerful language, and it's not like it can't do all the stuff that R can do. I'm also a little bit biased because I learned R, and I'm better at R than Python. Way better at R than Python. And I'm a little lazy. I don't always. I get frustrated if I'm hitting my head on the desk trying to do something in Python, and in the back of my head I'm like, I know exactly how to do this thing if I were using R. So that's been a bit of a limiter for me. But I would encourage you to learn both. It's not that out of the question. And also, I would say that like with the help of AI tools these days, programming is a lot more accessible. So
Like
you
I can just tell
you-
ChatGPT to write the code for me?
You can. It's a bit dangerous because it could
be wrong.
be doing something else. So it's always best if you are in a position to evaluate what it's giving you and make a judgment of like, is this what I want or not what I want? But it saves a ton of time because there's a lot of tasks when you're writing code that are kind of like onerous and pain, and it can knock those things out. So like putting together, writing some of the boilerplate code, that happens for free nowadays, which is really nice. And you can ask it questions. Like if you don't understand what is this thing, what is this part? It gets it for free. But, so you could use either language to complete the assignments, I would say. I mean, some of the stuff from R for data science, probably just wanted to use R because it's all R stuff. But like, this is an important thing, like the workflow and the conceptual stuff that we're gonna be talking about is applicable in both languages. And like, tonight we'll talk about data frames in R. There's data frames in Python, right? So, we'll talk about writing a function in R tonight. You write functions in Python too. So a for loop is in Python. If then else is in Python. So a lot of these concepts, it kind of boils down a little bit to syntax, but also to like the packaging around it, like the tools that exist around it that are like slightly different. But there is a bit of a commonality in the transfer there. If you stick with me for the R stuff, then when Professor Hayes is introducing some of the Python stuff, there's going to be a familiarity there that you'll hopefully click with. Okay, hold on one second. Okay. So now we're going to talk about like the workflow. So this is a very conceptual, no code here. We're just talking kind of like how this all typically works. So there's, we're going to return to this pretty much all semester. But this is like the data science workflow, right? So the idea here is you're gonna get some, we'll be working with data, right? So we'll be looking at data. So you're always gonna have to know how to like get this data into whatever you're working within your programming language, right? So you're gonna need to know how to import this stuff and put it into a format that is usable for you, and that's what this word tidy means. Put it into a format that is usable for you. Sometimes it just comes in a usable format, and that's great. And then you're ready to rock, and you can just start going on your merry way. But sometimes you might have to do a little bit of work to put it into a usable format that's gonna work for your modeling purposes. And then this sort of loop starts happening, right? Where you're going to be transforming your data. You're gonna be maybe creating new variables out of it, right? Maybe you don't want returns, you want log returns, right? Or maybe you need to transform your prices into returns, into log returns. So that's sort of the transformation. That's exploring your data and thinking about how maybe you could best express it, that the model will pick up on the appropriate signals. Visualization is a very, very important feature here. You know, like you could look at a big vector of numbers all day, but you'll get a lot more insight if you're able to sort of visualize it. And there's a lot of different types of graphs we can use and a lot of different packages we can use to do this graphing. And then finally, the modeling work, which we'll be talking about that. So that's about like distilling your data. You know, there's going to be some part of your data. Well, we'll talk about this. This sentence will make more sense to you when I explain to you what it means. But in a supervised learning context, there's going to be something within your data that you're trying to predict. Right, and then, so you're gonna be trying to see if you can get the signals out of these other portions of your data to best describe to you what's going on in that target variable. And then this thing can sort of like, can iterate, right? So you might find out more about your data, you'll need to put some more, maybe you need to go out and get more data and bring it into here, but like, you know, it's very rarely like, drop your data, click run model, and now my work is done, right? Because you're gonna wanna iterate and find the best one. And then communicate, we won't really get too deep into that, but that's always an important thing. So if you can't express to people and get them to understand what you've done, that's always gonna be a limiting factor for you. So the better you're able to tell people about what you're thinking and what you've done, then that's good. And there's a lot of tools available for doing that. So like for instance, I told you guys I do all of my slides with code, right? So this is written by code. So like there's packages and tools out there that help you communicate, right? So like you could build your model and then put it into a web app that would allow people to interact with it and understand responses and whatnot, that type of thing. We're not gonna do that in this course.
Do you have the code that put this together?
Yeah.
Like that you could show it? Not that I mean, I don't wanna derail, I just.
Yeah, I mean, yeah, real quick. And actually, you know, we talked, why can't I get this thing? Okay, good. And actually, in the, yeah, I need to minimize that. In the spirit of transparency, so I've been using AI agents, so they've been helping me write the code to write these slides. So yeah, this is called a QMD file, so this is called a Quarto Markdown file, and this code, for instance, there's that picture. So the workflow we will use all semester, boom, 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 and then it's not a loop. So yeah, you write your slides in more of a code type of a framework. I like it better than PowerPoint, even though like PowerPoint's nice because you can drag stuff to exactly where you want it on the page. But that's why I'm using ChatGPT, because I'll describe to it like, hey, I want this image to be here, write it out in the code. So this code file, and then here you can see like this render button. click that, and it can either create a PDF version or the HTML, like this is the HTML. We're looking at it right now. This is the, oh jeez. Sorry, I'm not the best with the Mac. I'm historically a PC guy, but I switched to Mac at some point, but that's such a bad thing. I'm still not the best at it. So yeah, okay, so, but you guys get it, it's an iterative process, right? When we're doing this stuff. And, you know, why this is a loop and not a checklist, because, well, in a financial context, you'll be you're constantly getting new data. In fact, it's a really hard thing to like make that cutoff, right? Because you could cut it off, build your model, and then some new crisis happens that your model didn't know about. And you always want to get that data in there and make your model aware. This actually happened to us. There was a banking crisis last year that some of our models needed to be updated with. Assumptions change, regimes change, right? The whole nature of the world could change. You know, you may find that new questions arise along the way. So it kind of, you do have to iterate on this, and it's not like just boom, 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 we're done. It's kind of never done. And then in a financial company like I work at, or that I've worked at in the past, like GE Capital or IBM, because of regulatory oversight, it's an expectation that like they want you to always be evaluating your models. So as you get new data, sometimes that new data isn't going to be used to build a new model, but you can use that new model, that new data, to evaluate how well your model is doing. Right? And then based on that outcome, that would be where that decision point comes. Do we need to build a new model, or is this one doing what we think it should be doing? So like the workflow rarely ends, it never ends, right? You're always getting something new, there's always a new crisis. And sometimes your model doesn't know about that and isn't of much use in the crisis, so that's a problem. That's always there. That's why, like, I think it's always good to have like the human sort of driving the boat, driving the car, so to speak. Because you know, people have seen crises in the past, and they can adjust accordingly. Okay, so like, you know, we talked about these steps: import, tidy, explore, model, communicate, right? Like, so in a finance context, right, like loan takes, macroeconomic service prices, returns, there's a lot of data out there, right? So if you're gonna work with it, you're gonna have to know how to get it into where you're working, right? So those could be Excel spreadsheets or CSV files, that's like a text format for sharing data. Lots of times you'll be able to access things like APIs that shows data. The Financial Reserve has a really strong set of APIs with all this financial data called FRED. And a lot of times in a programming language like Python or R, there are packages out there that allow you to get it into your system really easily. Like it's like, in fact, I can show you, we'll be looking at some stock price data, and I'll show you the script I used to load that, to get it, right? And then like tidying it up, so like this is about like bringing your data in. Once you have it, you need to make it work in make it usable for your modeling purposes. So that could be things like, you know, you might need to convert data types, right? So you might have your dates expressed as a string, January 20th, 2026. You need to convert that into a data type that is, the machine is interpreting as a date, right? Rather than a bunch of letters and characters.
Like a numerical format type.
Yeah. Missing data, panel data is a thing that we're not really gonna get too into, but you see a lot. It's like repeated observations of the same thing over time. there's a particular format for doing that. Exploring the data, right? So you're gonna wanna understand like, how is my data distributed? So when we talk about distributions, that's like a univariate thing, right? So do I have a lot of observations? You know, is it a bell-shaped thing? Is it a skewed thing? Is it maybe a bimodal thing? So you're gonna wanna understand how your data, the values that you're interested in are distributed. Where we talk about correlation, that's talking about co-movement between pairs of columns in your data, right? So maybe things are highly correlated, and that's gonna have big implications for if you are gonna be building a model, right? You're gonna wanna know and understand that. And regime changes, right? So lots of times in financial data, like one of the primary sort of features is time, right? So as time goes on, the world might change and things might, we call that a regime change, where it used to be this way and now it's this way, right? So it's just different. And we'll talk quite a bit about modeling, right? So modeling, we talk about regression and classification, but really you're always going to want to be thinking about how does this support the decision that's being contemplated. And then communicate, like I said, we're not going to get too into that, but it really, if you can figure out how to become an effective, a good modeler who is effective at communicating, you'll have more job security than the great modeler who nobody understands what they're talking about, right? So that's always important. Okay. I think we covered this one already, but if you understand what we're doing in R, I just want to sort of assuage people's concern if you're getting really worried about talking R and Python. But if you understand what we're doing in R, when you start seeing it in Python, those concepts will carry over. So there's portability here. And that's sort of, I'll stand behind that. And also you'll have Professor Hayes to help you out to get you into the Python sort of mindset. But so what actually transfers, right? So we're going to be talking, this is all data focused work that we're working on. So in these programming languages, the term is a data frame. So we'll be looking at some data frames throughout the course. But the way to think about a data frame is, if you're familiar with Microsoft Excel, you kind of have rows and columns and cells with data in there. That's a data frame in R or Python, right? It's a two-dimensional array of columns with data in it and rows with observations in them. The difference between R and Python, or not between Excel and a data frame in a programming language like R or Python, is that these data frames are more like a table in a database, in as much that like
Access?
In Microsoft Access, yeah. So or like a SQL Server or Oracle, or nowadays there's things called like Snowflake or these other things. It's that the columns have a dedicated like data type. So like in Excel, I can have a column that has, you know, the number 1, 2, 3, and then the next row down has, you know, the letters ABCD, right? So those, in that column, there's no enforcement of any strict data type. But in R or Python, like there is. So you need to, that column is going to be an integer, and you can't put a decimal into an integer column. Or that column is going to be a numeric column. I can't put the letter A in there. It's just not going to fit. So Excel is more flexible. Sometimes that flexibility can be kind of not your friend in certain circumstances.
Back to your original thing, but sacrificing some flexibility and all that.
Yeah. So in the modeling context, I talk about flexibility versus accuracy, or flexibility talks about kind of the ability for the model to sort of like hit the points that it needs to. That's flexibility, and we talk about interpretability. I've used this sort of spectrum a lot in my job. It's like flexibility, like Excel, I can type anything anywhere versus control, right? So you lose control when you give ultimate flexibility. But that's I don't think there's a lot of books that talk about that. So data frames, we'll be talking about functions and objects, where you'll see them, and just know that when you get to Python, you'll see the same types of things there. And libraries are kind of like, somebody else wrote you a bunch of code that you want to use. I'm going to use that code. How do I get that into where I'm at? So that's a library. In Python, that's called in R, that's called a package, and in Python, that's called a library. And then this is kind of the modeling workflow. So like when we're doing more of a data-driven programming type of work, you'll see that kind of, we call it wrangling. That's like getting your data in and putting it in the right format, visualizing, executing or estimating some sort of model, and evaluating that model. And then we will be talking a lot about like train tests. If you're taking statistics, this might sort of ring a bell, but like there's an idea of like, I'm gonna have some data available to train my model, and I'm gonna keep some data on the side to test it as well. And then you could have a validate data set as well. I think in this context, we'll just be talking train tests mostly, but you could do train test validate. Lots of times that validate data set kind of is coming at you anyway. I've built my model, I'm gonna put it into action, and like over time, there's gonna be new data coming in, and I'll evaluate the model there. Okay, so let's talk, I wanna talk a little bit about, we're gonna be using RStudio in this part of the class. So in the syllabus, it talks about installing RStudio, and hopefully you all can get that going. But I did want to talk a little bit about like, so what even is RStudio? So RStudio is an IDE, which that's more like a computer science type term. That stands for Interactive Development Environment. And that's different than R, right? R, I can download, I mean, when I first started using R, kind of dating myself, but like there was no RStudio and there was no IDE. So like it was kind of like I had a window that had like a blinking cursor, and I would copy commands, I would type commands in there. But like after a while you get tired of like on the fly typing commands in there. So I just had like a text document over here that I would write my code and copy and paste it into this console and get things going. So that console, that's just a blinking cursor, place to run R commands, is R. And the RStudio IDE is kind of everything around it that makes our life a little bit easier. So you can kind of think about like, R is like the engine, right, of the car. It's doing all the work, it's doing all the calculations. And RStudio is kind of the dashboard, it's the interface. It's how do I tell it what I want it to do, and how do I experience it, right? So I like this illustration here. It's good to know. It's not like the most important thing, but like just know that like, and it's the same with Python, right? Like so if you're using, I think that Professor Hayes will have you. Python's a little bit different. So lots of times people use a thing called Jupyter Notebook, which is it's not really an IDE, but it's a way to use Python. But like in that circumstance, like Jupyter Notebook is your dashboard. It's how you give it instructions and store your work and see your output. But behind the scenes, they call it a kernel. There's a Python kernel running that's actually executing these commands and performing the calculations. And then, think about packages. So this was kind of like that idea of like other people are going to write us code for us that we can use to do our work. if you think of R as like a new phone that doesn't have much going on in there, packages are like apps that we can install onto our phone to do special stuff, right? So we'll be looking at some of those packages, actually tonight. And they make it easier to do things like graphing, or working with data, or like a whole bunch of stuff. Like if you can think about it, in fact, at my job, I've written several packages that are specifically geared towards doing cash flow analysis. Okay, and then one other concept that I wanted to kind of hammer home. So this is facilitated in R and in Python, is this idea of a project. In Python, it's kind of called a folder, right? But it's just a way for you to organize your work, right? So in RStudio, we'll do a little RStudio walk through, but like the idea of a project is a very powerful thing, and really what it allows you to do is switch gears, right? So if you're working on one thing in one project, you can stop working on that and go to another project and start working on it. If you're not working within a project, it can get really easy to get your wires crossed, right? So like, let's say I'm a little bit lazy. Let's say I just call something X. X is this data frame, right? And I just call it X. And then, let's say I'm not in a project, I might start working on something else. And in that context, I use the variable X to mean something completely different. If I don't have these two things in two separate projects, I might start having sort of a bleed over from one piece of work to another, where like suddenly I'm thinking I'm working on the X that I'm thinking about in this project, but actually what's going on is I'm doing something to this X from this completely different project that I'm working on. So it allows you to switch gears, it allows you to switch work. And really it's not like super rocket science. It just means that all of the stuff for what you're working on live in one folder. And that folder is tied to an environment that has all of the stuff that you're working on in regards to that project, right? And then if you switch to another project, that stuff's in a different folder, and there's a completely separate environment running over there that's keeping track of that stuff. And if you're working with other people, which I do at my job, it kind of, when we talk about reproducibility, it's about like somebody else can come in and redo what I've done, and maybe take over for me if I get tired of working on that. I can hand it off to somebody else, right? So it allows for collaboration a little bit easier. So if you're going to be using RStudio, I would strongly recommend working in projects. So we'll sort of, I think at some point, we're going to do a walkthrough right now of RStudio.
Where would we get RStudio from?
So, okay, that's a good question. Let me just, real quick.
And just pre-requisite, I came with this guy, should I get myself a actual MacBook or laptop and actually come to class with that?
Is that so I'm not sure RStudio is going to run on an iPad.
Okay.
So I think you might need to, we can talk about it, there might be some sort of virtual machine you could sort of like get into. If you have access to like a laptop, then that's what you really want to do. Yeah. But I think there was a student last semester who was trying to set it up so that he could sort of have a virtual machine.
UConn has virtual machines.
Yeah, but the thing is last semester it was challenging because like the permissions there, like you didn't actually have the permission to install the packages.
No, they won't let you do that.
Yeah, so that was a big one there,
So I wouldn't be able to, I couldn't remote to my Mac at home, like I have a Mac.
I mean, you could.
Yeah, you could do that.
You could probably do that.
You have
Sounds
full
overly
administrative
complicated.
privileges.
No, I think that's,
As long as the iPad can remote to it, you could do it.
yeah, think that's not out of the question. And it's probably not like that hard. You probably just have to you could ask ChatGPT how to make that work. You're probably your biggest thing would be like establishing like a secure connection through all of the firewall stuff that you've done as to your machine and whatever you have on your end too.
Might be cheaper and less headache to just buy Island.
All right. All right, so, and then the question of, I'm gonna go back to the syllabus. So in the syllabus, I gave a little bit of, okay, so yeah, here's the links. So it's kind of a two-step process, but you kind of first need to get R, and then you need to get RStudio. So, but this is the link to get R. So you click that link, you'll see like a download button, and you can download R. And then this is the link to download RStudio Desktop, which is what we're going to be looking at right now. Okay, so quick tour. Where's my? There we go. Okay. So quick tour of the IDE here of RStudio. Okay, so the first thing you'll see here is like, if I go to File, right, I can create a new project. So this is like the project stuff, right? So like, if you were gonna start some work, right, or you could set up a project for this class. Yeah.
Can you zoom in a little bit?
Oh, yeah,
I'll
yeah,
move
I'm
closer,
sorry about
'cause
that.
yeah,
No, I can definitely zoom in.
I look at small stuff at work.
Actually, like, so I haven't taught since last spring, so this is like, blocking and tackling type stuff. You. Let me just. We're gonna make it like that. Is that big? That's big enough, right?
Yeah.
That's pretty good. No, I'm hoping that so the menu might not get that much bigger. But, this is where like, if you were gonna start some new work, you would do a new project and sort of tie that project to a folder that's gonna have all of the files that you need, and then when you write the code, you'll save out the file, like that code as in R, it's a .r file. If you're doing Python, it would be a .py file. But it's just gonna have everything that you're working on. So like, for example, in this project, so this is the project I have for the class. So like, this is where it is on my computer. I've got a folder called FNCE 5352 2026, and then this is actually my work. This is actually my project folder, and I've got a subfolder structure in there for like each lecture's materials and stuff like that, and assignments and whatnot. But you can kind of see this is kind of broken out into like quadrants. So like, don't get too freaked out by this, because it's not that crazy, right? So this is like the default layout. So when you download it, you'll see it kind of like this, right? But what we're looking at here is I've got one panel here that's showing me a file that I have open. In this case, this is that presentation coding language that I was talking about earlier.
It's the PDF.
So that's a QMD file, but this thing generates the PDF and also the HTML slides that we were looking at. But I could open up other kinds of files here. So the other sort of quadrant I have is in the lower right-hand side. This is just showing me all of the files that are available, like in my directory that I'm looking at. So in this case, I'm in the lecture 1 folder. And we will do a live demo. So if like I open up a file, live demo, then it kind of shows up in my file viewer. So I can have multiple files open at any given time. And I've got some sort of like, I can save the file, I could run the code in the file. And these like extra, sort of, buttons and commands are kind of change based on what kind of file I have open. So you can see like it's different. I'm looking at a .r file. This is pure R code here, whereas this one is that sort of more presentation type code, and I get different buttons there. Right? So I have a publish button. If I want to publish this thing, I could do that. So I've got my file viewer one. I've got this tab down here, which has like more of my directory stuff, right? This is like my almost Explorer window. And I've got other tabs here, so if I do any plotting, it would show up down here in this plot window. We did talk briefly about packages, but I can get an interactive sort of view about what packages are available, what I have installed. I can load them over here. I've got a help window, right? So if I ask for help, it will show up down here. So this is like a sort of a functional panel down here. And then we'll talk about this environment panel, but this just shows me all of the variables and objects I have loaded in memory that are available for me to do stuff with. So this is something that frustrated me a lot when I started working with Jupyter Notebooks, because I always was not really on top of exactly what was available, like what had I loaded into my memory, into my environment. Right now my environment's empty. And then I've got some other tabs up here. Like this will show me all of the commands I've run. Connections we won't be using so much, but like if I work in a place that has like databases, I can connect very easily using this panel to like a database. And then I use this one extensively. This is Git, so this is like source control and tracking changes in my code over time and pushing my changes to different places. Now, we're not going to get too involved with that, but if you're interested, we can talk about it. And then this, so we covered like the file viewer panel. We covered like this panel that shows my file explorer. We'll see this environment panel change during the live coding session. And then this panel down here is called the console. So this is actually where I execute code down here. So like, this is a bunch of stuff that kind of just shows up telling me that like, I've got it like basically one version of R am I running, and this is like boilerplate, like messages you get when you start R, right? But then this is the important thing. So this is the cursor, right? So that I can type commands down here and have it run stuff. So, well, we can kind of, well, we're going to do a live demo. So that's like the quick tour of RStudio. As we work with it, you'll kind of see it more in action, and you'll kind of get, hopefully, a better sense of like what else is going on. But the whole idea is like I said, when I first started, I only had this, right? So I only was presented with a blinking cursor that I could type code into, right? And working in this thing that's called an IDE is like a much better experience. It makes your life a little bit better because it gives you a lot of stuff that's going to help you understand more about what's going on. So it's all about like being able to see what I've created, understand what's going on, understand what's in my folder, what I have available here, and like I said, I used to only have this thing, and then I would have on the side I would have like a text file that had a bunch of code in it, and I was copying and pasting between the two. This very much facilitates a lot more activity. Makes it a lot easier. So before we go to get out of here real quick. Let's see if had lost this, I didn't lose it. Before we go too deep, and then we'll do, after this, we'll take a break, we'll take like a 10-ish minute break, I think. And then we'll do like a little bit of like live coding. Before we go there though, I did want to mention this, because this is like a new thing, and this is, it's so new that I haven't yet completely switched gears into this new IDE that's out there called Positron. But I did want to mention it because I use this a lot at work now. So, and I think going forward, I probably will start using RStudio less and less and start using Positron more and more. So this is a new IDE that the same company who makes RStudio came out with, and it's called Positron. And it actually has a couple of compelling features that may make it something that you would want to consider thinking about. So let's see if I can make this thing bigger too. Okay, so I think I can do this. Okay. So similar idea. Similar idea to RStudio, right? Like you see a lot of the same stuff, right? I have a plots window and a session window. I've got kind of like different quadrants here. Because this is like in dark mode, right? I guess I should maybe make it in light mode to make it a little more, if I can figure out how to do that. I don't even know how to do it. Okay, you're just gonna have to kind of like stick with me here while I describe this. But the idea here is like, it looks a lot like the other one, but it's got some nice newer features. So the couple features that it has are, RStudio is only for R, but this thing can do R and Python. So if you want to work in Python and do data type work, you could use Positron, and you wouldn't have to switch gears if you're switching between R and Python. It's got like this. Has anybody done any like programming with like the IDE that's very popular amongst like real computer programmers is called VS Code. Anyone familiar or heard of VS Code?
I've heard of it, I haven't used it.
Yeah, so this is based on VS Code, so it has a little bit more look and feel of like those tools that like real programmers are using. So it's got like this search bar is like super functional, like you can find all kinds of stuff, and it's built so that like it's a little more integrated. The thing that I really like about it, the two things that like really stood out to me that told me that like, hey, well, the three things that stood out to me that said, hey, I might really want to start using this in favor of RStudio is the Python thing, right? So that we can run, if I'm working with someone who's using Python, I can have this around that allows me to do it. One other thing is I use at work, there's two AI sort of things I use. One is ChatGPT, everybody's familiar with ChatGPT. But then this one, and the one that like real programmers use is something called GitHub Copilot. I don't know if anyone's heard of that. Well, what's really nice is like this has a fully integrated like chat feature that's like hooked up to in this case it's GitHub Copilot, but like I can interact with the AI agent here directly, and the AI agent has full contextual understanding of everything that's going on in my project. So like at work today, I was like, I wrote all this code, I wrote this package. And then I went into this pane here, which is called Positron Assistant. And I said like, evaluate my code and give me 10 things you think I should change about it in order of priority, and then also like an estimation of the time it would take to do that. and it was like, bup, 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 bup. Here's your 10 things that you should be worried about, boom, 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 boom. And like, I can ask the agent, but I can also have it be an agent. So it can actually go into my code files and edit the code, like, not autonomous.
But isn't that like give a man a fish versus teach a man to fish?
Well, I mean, I know how to fish, right? So, yeah. No, it's dangerous, but, you know, it's like we were saying earlier, right? Like, if you're using it to facilitate your work, and you're driving the boat, driving the car, and it's giving you feedback, but at the end of the day, like, you're making the choice, do I wanna use this or not? Like, it won't just edit the files, it'll edit it in such a way that I need to go in and approve the changes.
Got it,
And then, you have this sort of plan, mode where, I was kind of using the plan mode where I was saying like, what do I have to do? But, so, I think though that the AI integration into Positron is kind of getting to a really interesting place. Like I said, with great power comes great responsibility. I think Spider-Man's uncle said that. And then the other thing that's really nice here is if I do have data, I don't think I have any data here. I can just say like, there's actually in R, there's built-in data sets, so I know some of them. If I spelled diamonds correctly. Ah, man.
Go for cars. Cars is easy to spell.
Car, okay, yeah, good, let's see, cars. Okay, yeah, so you've got this sort of built-in data viewer function that is really nice because it sort of presents my data in a format that is, looks like it's kind of like Excel, right? But it also gives me some information about what's in each column. In this case, I think there's only 2 columns. I thought there's more columns in cars, but maybe this is a weird cars. But it's good for this illustration because it shows me my data, but then it also shows me on the side here, like, for more information about my data. So what this is telling me is like, this is how this data in this variable dist is distributed, right? And then how much of it is empty. So 0% is empty. So there's no missing data in here. Gives me some information about the distribution, and then it also sort of, I can click in here and it'll give me like even more information. No missing, this is the range, min and max, median, mean, what's the standard deviation, right?
So let's say you delete 9, it'll show missing data then.
I don't know if I have the ability. I think typically I would be able to edit this, but because this is a built-in data, it's not really, it's more like read-only. But you could also edit the data interactively in this thing. So it's pretty, that's something that like RStudio doesn't give you, and not a lot of, like if you're using, a lot of this like coding stuff, right, if you think about it, is built specifically for software engineers to write code to build apps or do whatever they're doing, like do their data engineering stuff. This one is built for data analysts, data scientists, and statisticians to do what we do, which is a little bit different, a different coding assignment than building an app. You know, we're trying to think about that cycle, right? We're loading in data, we're looking at the data, we're asking questions of the data, we're trying to model the data. So it's a little bit of a different pattern than a real software engineer. So like, that's the thing about this Positron thing, and I think it's very new, and I'm kind of new to it, so I haven't yet integrated it into this course. But I think at some point I probably will be more teaching Positron than RStudio. I just wanted to tell folks that this is out there, and it actually, it's the AI, it's this data viewer. It kind of might seem like oh, that's kind of cool. Like, this is very cool, I think. And then the idea of like, it's not language specific. So if I want to switch to Python, I can switch to Python. If I want to do R, I can do R. So it's really kind of a a cool thing, so if you wanna check it out, Positron. So it's that link in the syllabus to download our studio, so posit.com. You can also download Positron if you wanna check it out.
It kind of looks like PyCharm.
Well, yeah, I mean, it's built on top of VS Code, so it's like PyCharm and VS Code are sort of in the same family. I mean, our studio also sort of has that stuff, but it's a little different. It's built for R and R only. So I'm very comfortable here, so it did take me a little bit of time. Like, I work with people who are like way younger than me, and they like immediately were like, we don't do our studio, we just do Positron. And now, like that AI assistant thing, I mean, I've been working to do work with, at work with AI, more chat type things. And a lot of copying and pasting back and forth between the chat window and then my code. And this is a lot more integrated. And also it knows all of the context. Like, I'll just show this thing. Like, so for instance, here, okay, so I'm looking at some sort of something, right? If I'm interested in talking about like this bit of code here, you can see that like this chat window has sort of updated. It knows that I'm looking at this file, and it also knows that like these are the lines that we're talking about. So it's like very contextual, right? So if I were to say like, what is this plot doing? It knows exactly what I'm talking about, right? Like it knows all of that context, which is kind of cool. And then the other thing is like with, I don't know, are people very familiar with all of the different like AI models that are out there these days? But so for instance, I pay for like the cheapest one. This is my home account, right? So I don't pay for like the full. I think it's $10 a month to get this. It'd be $40 a month to get like all of the whole thing. But so these are describing OpenAI models that are out there right now. At work, we're using a lot of this 5.2. It's pretty good. And then they have a 5.2 thinking, which takes a little bit longer. So those are really good. But these are sort of a little bit more general, multi-purpose, and more chat focused. These ones are from oh, I'm drawing a blank on the name, Anthropic. So these are like Anthropic models, and these are, their specialty is code, right? So I don't pay to use these, but at work I have access to them. So these are, everybody who I've been talking to are like, these are like really, really good at any coding exercise you want to do. These know how to do it. And then I think these are the Google models. I haven't used them much. I think there's even in this list. This is the former Twitter model that's out there. Anyways, that's the thing is like with this. This is called GitHub Copilot, but really it gives you access to a whole suite of a whole lot of models that are out there that are being made available by all of these different companies. OpenAI, Anthropic, Google, X. So they're all kind of in there. I just don't pay for all of them, so I only use, this is the only one that I have availability to. And this is good for like for most coding tasks, but it's sort of less good at like asking questions about like planning or like architecting code solutions and that type of stuff. Anyways, so if you want to check it out, Positron. It's pretty useful. All right, let's take a little break, and then we'll do some live coding, and then we'll like wrap it up for the evening. All right, let's do like 15 minutes. remind me to turn on the recording again, Russ. We'll only have half a class.
I'm recording it anyway.
Oh, okay, cool. Are you recording like me up here, or are you?
Yeah,
Okay.
it's just a screen thing.
Yeah. So Ed said you were in the class, so I think this is the first class I've well, I only took
Yeah.
one class, so you've not taken this one yet.
I did the 3 modeling last year,
Okay,
but I've also done a lot of the economics courses.
cool.
And that's probably what I'll go do for PhD economics after this.
Nice, nice. Yeah, he was telling me the setup. As a Connecticut resident,
Yeah, once you're over 62, it's free.
Yeah.
You gotta, this free tuition, but you gotta pay the course fees or whatever. So it's like a couple $100 per credit.
Okay.
I think it's gonna be like $2,000 a year. In the summer, they won't pay for the courses either, but
Okay. Oh, cool.
he checked out Rutgers after I told him.
Oh yeah. But he didn't. I don't. They don't. They don't have the same thing in Jersey. Or?
No, he said, yeah, he checked out Rutgers, didn't have it.
Yeah. Yeah. Well, I'm looking forward to it. Pretty soon enough, I'll be able to take advantage of it. All right. I'll be back.
event don't give you?
Uh-huh. Well, it's only small, medium, and then it'll be large, or extra large. It depends on how he wears his hair. If he's gonna wear it out, he's gonna need a bigger hat. I would say get a large. I say get a large. Yeah, get a large. Alright, man. I don't necessarily need a powerful machine for all of this
No,
stuff.
I don't think you do, no.
No?
No.
Man, I come from the VBA days.
Oh.
This is uncharted waters for me. My juniors, they're the ones that give me this stuff and the models and stress test, but I never get into the back end like this. So this is gonna be an interesting class.
No, you can use a regular PC or Mac, it's whatever works for you, honestly, whatever you're used to, so,
We've transitioned to the Mac world. I just don't know if I know they don't communicate as well as they should, but I know they communicate now, PC and Mac, so.
yeah, in that case, yeah, if you like the PC environment, then yeah, stick to any regular PC, it'll work fine.
PCs are cheaper now.
Yeah,
Getting
yeah.
a MacBook, I gotta spend $1,000 on a MacBook.
Yeah. Yeah, they're expensive. You say you stress test without using any tools, just?
No, so, a lot of the private wealth stuff that we do, we build internally. We've never, like, maybe outside of Argus, we use Argus and we integrate with those, but other than that, I never have to get into this.
Okay.
This is, I'm 10 years past all this, and
Gotcha.
this has gotten much more robust, so I said, hey, I'll just go dig into it and fuck. I don't know if I can dig into this.
So you say you work on one of the private, wealth companies?
I'm a family, I work in family offices. Like, that's what,
What's that?
you don't know what a family office is?
Family office for like what, like?
No, I work for a family office.
Oh, like a local.
Yeah, like I'm
a mom and pop
I'm
shop,
the
basically.
assistant CIO, like I have now progressed to a part where I don't have to build anything.
Okay.
I'm doing the analysis and figuring out whether we wanna do a deal or not.
Gotcha, okay.
I used to do the grunt work. The grunt work I used to do a lot, Black Scholes and all that kind of stuff. That was all just regular old Excel work, and I could just build formulas and to do all
Gotcha.
this stuff. Things have gotten more robust over time, and I'm trying to catch up.
Sure.
Shit, I think I missed a boat, and I should have did this about 5 or 6 years ago.
No, it's never too late, I don't think so, no.
Well, learning a program, I mean R. I've never even heard of R. Python, SQL, yes, and I know rudimentary stuff with those things. R, I've never even heard of.
I'm just surprised that R is still a usable language in the world we're in today. I thought everyone uses Python.
Yeah.
Python is the main one everyone uses, but
That's the one that I've been exposed to, so I can see rudimentary stuff like that.
I'll be curious to hear his perspective on, like, does he really use R that much? I mean, like, in
It
his
sounds like
organization.
it does.
But do other companies do too, so I heard of SAS, I'm not sure if SAS is similar to R or not, but, I'd be curious to see his perspective.
I'm hoping he would just show me, hey, just give me some basic code that I can start playing with, and then I can build off of it.
Look, ChatGPT will be your best friend. Yeah, I kid you not, it helps a lot, it really does.
Really?
Yeah, you can tell ChatGPT, hey, write the code for me and write it for you, but you need to know, like, understand what it is.
Yeah, cause I gotta
The
be able to
syntax
review it and I
that.
gotta understand like,
Yeah.
okay, was this written correctly?
Right.
So, that's the one thing.
For the most part, it does write correctly, but sometimes it does things complicated than it should be, and that will, and then it'll be obvious that you're using AI to help you out with that,
Got it.
yeah.
Well, he said he's willing to hold hands, so I'm hoping he holds my hand.
Okay. All right, so let's get back into this. We're gonna do a little bit of live coding, but it's not overwhelming. So hopefully, it's not underwhelming. Hopefully, it's the right amount of overwhelming.
This is all riveting, it's actually overwhelming right now.
Alright, so.
You have to restart the recording, right?
Yeah, thank you, yes. Let's get it going here, turn on the mic. Yes, so we're gonna put Positron, because we're doing this in our studio. So I'm going to kind of start the recording, and then we'll get going here. All right, so I think we're back on. So hopefully we have enough real estate here that you all can see what I'm doing. And also, we can sort of see the effects of what I'm doing as well. So, as I said, in our studio, you kind of have these 4 panels, and you can configure them in different ways. This is pretty much the default. So one thing is that, so I have opened up this code in the code editor window up here, right? And in R, if you have a number sign here, that indicates a comment, right? So what's nice about in R Studio is that it does like color code what shows up here, right? So this is all green stuff, so like none of this is gonna be executed. I couldn't even execute it. Well, if I did execute it, nothing would happen because it's a comment and I have the number sign at the front, right? And you can put these comments, you can write some code and then put a number sign at the end of, sort of after the code with a comment about what that code does. And that still works too. So you can comment like this, which is kind of like a block. And like transparency, ChatGPT wrote this for me when I was sort of doing this. Actually, I was re-engineering stuff I'd done in the past, and I was asking it to help me sort of put stuff together.
So everything here right now are just notes.
They're
because
just
they've all got-
notes, yeah, so, and it's good coding practice to put comments in your code, so that like somebody else coming to it later on, will have some context about what's happening. And sometimes that somebody else coming to it later on is you in 6 months, like that happens a lot too, it's like, so commenting the code is always a good idea. Okay, so we talked a little bit about packages, right? So in this code, I need to have these lines of code that indicate what packages need to be loaded for me to run this code, right? So we talked about like a package is kind of like an app, you can think about it. But so if I don't execute these 4 lines of code that start with library, like some parts of my code won't work. So some of the functions that I've sort of sprinkled around throughout this thing rely on these packages.
How do you know which libraries to use? I'm sure there's thousands of libraries.
There's a lot, and I'm using like the ones that I'm most familiar with, but are also like tried and true ones. So the one that we'll talk about quite a bit is this one called Tidyverse. So this is a package that one of the authors of the book that we are using, R for Data Science, Hadley Wickham, he wrote this package. So this package it's a little bit of a special package in that it's kind of like, it exposes you to a bunch of different packages. So it's like a bunch of packages that are very, very useful for doing data work. So graphing, tidying up the data, calculating different columns and data frames and whatnot. So this one is Tidyverse. These other ones are more helper packages. So we'll talk about this here packages. This package is more for like working with files in your project. So it's about like finding, if it's in a folder, like it'll help you sort of write out the file location. So I use that. This one's about working with dates, Lubridate. And then this one is just about, it's a graphing package that we use. So that's part of the learning curve, I would say. It's like knowing what packages are out there and which ones you want to use. But you do get a lot of bang for your buck with this Tidyverse package. So I did want to talk about like the idea of packages in R. So one of the things that you have down here is this packages tab. And this will show you all the packages that are available to me. So that means I've installed all of these packages. There's two verbs that we use when we're talking about packages. You install a package once, and that just means you've downloaded it and it's available to you and it's been installed on your computer for you to use. So like these are all packages that I've installed. Lots of times packages depend on other packages. It's called a dependency. So I didn't actually install, for instance, I've never even heard of Anytime. But one of the packages that I've installed at one point has a dependency, needs Anytime. So when I installed that package, it just doesn't install that one. It says install this package and all its dependencies. And all of those packages dependencies. Sometimes it can be like that. So you see here, like I've got a lot of packages that I've installed. But like I said, I probably have installed 10 or 20 packages. And these are all of the dependencies that those use. So the thing about the install, right, is you do that once, right? So if, let's say there's a package, I'm trying to think of a package that I haven't installed that I might be interested in. Like for instance, I know of one called Stan, right? So if I type library Stan, it's gonna try and do an autocomplete here. Actually, it might work because it seems like it knows what's going on. Okay, here, so it's telling me like, there's no package called Stan. I would have to install Stan, and I would only do that once, right? And I would do that using this, there's two ways to do it, right? I can use this function here, install.packages, and I could say Stan, and it would know, RStudio knows how to go get packages. So there's a place that those things live at, it's called CRAN.
There's a data link with that.
Yeah, there's like a place out there that has all the packages that have been published. And if I say install packages, RStudio knows to go there and get it and bring it down and install it. The other way to do it is because this is like an IDE, right? It's a little bit hard to see up here, but if I go to tools, I have like an install packages and I can do it via like a window here that would do it, right? So here it's saying like, where do I want to install it from? You wouldn't even ever really like update this thing. You would just say like, just go to the place you know where to go to get this thing. And then I could start typing out, and this is nice too because, well, I guess Stan isn't actually, I think maybe it's a different one, but you kind of get the idea, like maybe I would want to install, yeah, it kind of does an autocomplete, so it kind of knows what's out there. Right? So you could use this thing, right? So the difference between installing and then loading here, so I can have a package installed, but until I say library tidyverse, like it's not actually, it's installed, but I haven't told it that I want to use it. So that's like telling it like, load the package. Cause if it always loaded all of the packages that I have available, it would kinda get cumbersome, right? So it's kinda, maybe a little bit of an opportunity for overload there. So you need to like load the package, and that's what this thing is. Alternatively, like I've not loaded, here, for instance, EFG, right? I could like click, like, I could use the IDE to load the package. I could click that that checkbox and load the package. But, like, if I execute this line of code, right, and how do I execute it? Well, one thing I could do is I could copy it and paste it down here. We'll talk about a shortcut. But if I refresh this window, I should see like a little check mark. No? I was expecting to see like a check mark next to that here. Hold on. Hold on. Yeah. E, F, G, H, no, I don't want to do it. All right, well, I don't know why it's not checking that, but it's supposed to check. Let's not dwell on that, because I never use that window anyways. But, okay, so I want to talk a little bit about, you saw that I like went here, I highlighted the code, I copied it, and then I pasted it down here. That's kind of a painful operation. So the other nice thing here is that I have some options here. This is the way I do it. You can hit either Control if I'm on a Windows machine, you hit Control, Enter, or here I'm gonna hit Command Return. And it just takes the line of code that I'm on in the code editor and sends it to the console. And if I have a bunch of lines highlighted, like if I select several lines, and I hit that Command Return or Control Enter, it'll take that entire chunk and send it into the console. So what's happening when I did that is that all of that code, and in this case, this is like very interactive code that's telling it to load some libraries on my behalf, gets sent down into the console, and now I've got functions that are available to me to run from those packages. So like, that's kind of a, I don't know if that's new to you, that'll take a little bit of time to get used to. And that's very similar to sort of how it would happen in Python. You're talking about Python are libraries rather than packages. And then you would, I can't remember that, you would tell it somehow like, I'm gonna use this library and make it available to me. And also, you would also have to do an install if you hadn't yet installed that library yet. And that's here in R, it's called cran, and in Python, it's called pip install, I think. Anyways, okay, so that, we just needed to do that up front. Lots of times you'll put like in the beginning of your code file, if you're using packages like that, you would put like a, you know, I'm gonna use these packages, and that would be sort of like, almost like a header in your file. All right, so let's just talk a little bit about like what R can do. So like, I can use R as a calculator here, right? So I just sent that line of code 3 + 3 into the console, and it added 3 + 3 and it returned this number 6. So it did the math for me, right? What's interesting here is that it is telling me a little bit of extra about what's going on. And this 1 here is telling me that like, this is actually a single number, right? A vector of length 1, we call that sometimes a scalar, and it's a single value with the value of 6 in it, okay? And then I can also, like, there are functions out there, like in Excel, right? I've got worksheet functions. I think that in Excel, SQRT is the same, right? It's a square root function.
Mm-hmm.
But I can use functions, and I can say like, just do the calculation for the square root of 2, right? And this is once again telling me this is a scalar number, and it's a single value, and it's 1.414. You know, if I didn't want to use a function there, I could do the math and I could exponentiate it. I could say 2 caret 0.5, and I get the same thing, right? So, you know, you can do that stuff. We can nest functions, so let's say for some reason I really cared about this value, the square root of e to the square root of 2, right? That's how I would write that on paper. I can nest these functions, so, and you kind of read this from the inside out, right? So I'm going to take the square root of 2 first. I'm going to exponentiate it, e to the power of the square root of 2, and then I'll take the square root of that, right? So here, once again, I'll hit Command Enter, and I'm getting that value. I did not know that was 2.02, but that's what that is. And then, this is kind of nice. If ever I want to have help on something, I just type in the console question mark. And for instance, if I want to know help on that function, square root, I'll get something popping up in my help viewer here. And this is, they don't have a dedicated like help page for square root, but absolute value, square root. But pretty much anything that's out there, if there's a function I'm using, I can do question, in the console, I can just type question mark, and then the either the function or, you know, here I can say question mark cars. We were looking at that earlier. And this is a cars data set. Oh, you know what we were looking for? MT cars is the name of the one that I was thinking of. That has a lot more information of make, model, mileage, that type of thing, cylinders. This is a little bit of a simpler one. It's got two columns. So like for instance, question mark MT cars, Motor Trend car road test. This is a much richer data set. But question mark is a really powerful thing, right? It'll help you out. And then like, you could do like, if I do 2 question marks, then I can search for stuff like, it'll kind of do more of like a search, right? So if I do like question mark, reduce, right? It'll kind of look for all stuff that have the word reduce in it, right? So it'll give me links to resources I can use. So, pretty, not too bad. So 2 question marks is kind of like a search type of a, search the help, what's available for help on something called reduce. Okay, so that's like basic sort of stuff. You can see here that we're just kind of like operating in the console. We're not really interacting with stuff outside of what we type here. Although like these functions are somewhere, right? So they're in kind of like the base R. We can also create variables with code, right? So, and R has a special character that like, it's kind of unique to R, is like a less than and a dash. So that's like the assignment operator. So what this is saying is like, take this and put it into a thing called X. If I execute this in the console, I want to draw your attention to this environment pane here. If I click Command Return, you'll see that like I now have a value in my environment called X that I can do stuff with. I kind of created something in my memory that I can use later on. Right? So now when I say X, it knows that X is a number 8.
So you would use that X inside that formula that you have there, that you wrote on the whiteboard.
Yeah, so I could do, I mean, if I wanted to, I could take the square root of X right now, right? Not Z, but X. And it'll give me the square root of 8, right? So I can use this as an object, right? It kind of depends on what function I'm calling. Like this function is looking for a number, right? And X happens to be a number. If I said like, say I changed it and said like, Z is the letter A, right? And I tried to do the square root of Z, it would give me an error because I can't take the square root of the letter, right? And then we do have, I kind of alluded to this before, right? Like even when I have a single number, it'll tell me that this is like a vector of length 1. Everything is kind of stored as a vector, so I can create vectors too, right? So like I can create a variable called y. And by the way, that assignment operator can go the other way, right? Like, so I could say, and you rarely see it, but like sometimes people use it. You can sort of, this is equivalent to, let me just copy this so I don't type that. Hold on, what did I do here? I could put it the other way, so I could say like, take this thing and put it into y, right? So it's, most people only use this one, but, yeah. Anyways, so this created, we can see here in my environment now that I have a variable called y, and it's got a number in it, but it's not a single number, it's a vector of 5 numbers, 1, 2, 3, 4, 5. So this function C is like a special, like a base core R function. It kind of stands for like concatenate or combine. I mean, you can do question marks, C. Get rid of that, put that. Combine values into a vector or a list. So it kind of puts stuff together. So it took all of these numbers and it combined them into a single object, which is a vector of 5 numbers.
Well, what would you use that for? Like,
Oh, yeah, you use that for all kinds of stuff. Like, we use it, so like, when we do our cash flows, we don't think of them as having a particular date. It's like period 1, period 2,
Oh,
period
period
3.
two. Oh,
So I
okay,
could say
yeah,
like,
gotcha.
if I know I have to go out for 36 months,
then
I
you
would
have
go
a vector of 36.
Of 36, 1 through 36, that would represent those. And the thing is I don't need to type all those numbers out. I can do 1:5, that's kind of like an R shortcut. So if I wanted to do 36 months, I could do 1 to 36, and it'll create this vector of all the sequential numbers between 1 and 36. And if I print Y to the console right now, it'll show me 1 through 5. Yeah, so vectors are like, vectors are really important, vectors of values. And then also, like, you can extend that, there's another sort of object type called a list. So you could have a list of, like, all different kinds of stuff, right? In fact, when we talk about data frames, those really are lists of vectors. This is sort of behind the scenes, but that's what's going on there. Those are like, each column is a bunch of numbers, and I've got many columns, so they're kind of stored as like a list of vectors. And each vector has the same length. So I've got this number x, right, and this number y. But y isn't a single number, it's a vector of length 5. Like, what would happen, do you think, if I did x plus y? Right?
Add 8 to each of these guys?
Yes, exactly. So it would take 8 and add it to all those numbers, right? So this looks like I'm adding 2 things, but I know behind the scenes that one of these things is sort of has a dimensionality to it. So this is kind of a feature of R. It's got this idea of called recycling. So basically what it did is it said like, well, I've got 5 things. This thing has only one thing in it. Let me just sort of make this long enough, have the number 8 represented 5 times, and I'll add those numbers together. And so recycling also can happen in other ways. So let's say like Z is equal to like C 1 comma or 3 comma 4, right? So I can add Y to Z, which is a little bit weird, right? And it does it, but it does give me a warning in this case, because this one is a little bit, the X being a scalar value and the Y being a vector is kind of a typical thing. Adding together 2 vectors of differing lengths is a little bit weird. It still does it, I get the answer, but it does like this recycling thing. So this actually gets converted into like 3, 4, 3, 4, and then another 3. So it does the math, But it does give me a warning. It says like, hey, that doesn't really work that well. One thing that I'll say about the R programming language is that like, it is written by statisticians for statisticians. And it does, like, in a lot of programming languages, like this type of thing, where I'm trying to add something of length 2 to something of length 5, would say like, no, I cannot do that, right? It would be a no-go. But R is like very forgiving, so some people like really like that. Like, it'll give you a warning, but not an error, and it'll still try to like, in its own way, try to make it work. A lot of like true like computer science people like hate R because of this, because they would rather it say like, not allowed, don't do that. R is very forgiving, it tries to work with you and guess. I want to say guess. It'll try to not give you an error, it'll try to sort of give you something and then give you a little warning. Okay, so that's what happens if we add X and Y, even though they're two things of two different lengths. I can create a sequence. So we saw I could create a sequence by using that colon thing, but like there's a function sequence, so I could go from 0 to 10 by 2s. So there's like different ways to create these sequences, and these are can be kind of useful. And then the other thing that is helpful is I can get information about my what I have. So here I have this vector, numeric vector y, and str is like the structure of y. So it's telling me it's a number, it's got elements 1 through 5, and these are the values in there, and they happen to correspond to numbers 1 through 5. But this, I would say for like a numeric vector, inspecting the structure of that is kind of like a bit trivial, but like when you get like bigger, sort of more complicated structures, lists, you can have lists of lists. These things do get kind of complicated, so like this function is kind of very helpful.
Is R this intuitive, or is this just a rudimentary what R can do?
This is what R can do, because you know, okay, like great, I can add 1 and, you know, 2, 3 and 5, cool, but like you gotta layer on complexity to actually do stuff you want to do, right? So this is more of like a gentle introduction to R. So the other thing is like we saw functions earlier, right? Like we saw this SEQ function, the str function, the square root function. You know, we can write our own functions. So this is like a declaration of a function, and we're using that same assignment operator, and this is a special function that creates a function, right? So here, if I hit that command return, now this curly bracket thing is kind of telling me like, despite the fact that this thing takes up 3 lines, it's a single statement altogether, right? So opening curly bracket, closing curly bracket, right? And I can define my function.
Why is it done that way and not just on one line?
Well, in this case, it would be very easy to do it on one line. Sometimes my functions, like I said, get more complex than just adding 2 numbers together. So like, you need to span several lines, right? Like, you know, you could have a function that, in order to define the function, it takes 100 lines of code, right? You're taking something in, you're doing something with it, you're sending it over here, you're sending it over there. You know, you can have, these do get quite complicated. So like, you need a way, you wouldn't want to just have that all on one big line. You would want to be able to sort of make it readable. And you know, you can indent and do all kinds of stuff, add comments to make it more readable. But you saw what happened here, right? I defined this function. I put my cursor sort of anywhere on this line. I hit that Control Z, And it was smart enough to know that, like, send all those 3 lines down to the console down here. So it executed this code. Also, you see, the other thing that's a little bit interesting is like, when I run code that does this assignment, it doesn't return any results. But what it does is it creates something in my environment that is now available to me. So I've defined this function, and I can call it, right? So I can say, add pi 3 to 3, pass the number 3 into that function, and it's gonna add 3 pi to this number 3, or not a particularly close approximation of pi, but in pi, it's pi enough, you know? And then I can also sort of pass my vector in there, and it'll work just as we saw before. It'll add each element of that vector, it'll add pi to. Right, so defining your own functions can be very useful. I don't think, we're not gonna do like too much of that, but it might pop up here and there. This is how we define functions. And this sort of idea, I may be using the term wrong, functional programming, but like, by doing things to write, by organizing your code around writing functions, it's a very effective way to sort of make your code less verbose. Like, you end up copying and pasting a lot less code if you sort of define something once and then reuse it later. It's a good approach.
And R will remember all of those things in the environment.
Yeah, exactly. So one of the things that I turn off, it's a good question. If you go to Tools, Project Options, right? General, okay, yeah, here. I turn this stuff off because I don't like it, but like, by default, it's gonna save your workspace to like this file called RData when you close this project. I turn it off, but like, you can leave it on. So when you close your project, it'll save all of this stuff into like a file that when you open it up, restore.rdata into workspace at startup, it'll restore those all back. So like, next time you open it up, if you've got a project going, you'll be able to pick up where you left off last time. I turned that stuff off because it's like, I'm sort of at a point where I write my code so that I can just I can create what I want when I want to happen. I don't really rely on that being around like that, but it's not a bad way to start, right? It's not a bad way to start. Okay, so we talked about like, these are objects that we're creating in R. They're data objects. This one's a function object, but kind of everything does eventually manifest kind of as an object. So we talked about creating objects. We talked about how sort of different shaped objects kind of work and interact with each other. This next thing is like a very specific R thing. Like, I don't think you're gonna see this in Python, but like, this is one of the reasons why I really like R. So this makes R code very readable. So like, if we had let's do this thing again, square root of e to the square root of 2, right? And we kind of talked about like this version, right? Where I can execute this and it'll calculate 2.02. I would say like there's some issues with this. And the issues are that like, the thing I'm starting with is this number 2. And I kind of have to start in the middle and work my way out. And also like, this is a thing that is very I've seen a lot in Excel when people work in these big Excel spreadsheets, where you have these, especially if you have like conditional logic in your worksheet function, you'll have an if else then, and it's like people put that into that, into that.
Index match, all those. Kind
Yeah, and then you end up with like 50 of these closing parentheses, and it becomes a real pain to sort of figure out, does this parentheses, it helps you out, it'll sort of highlight which one is which, but it's like a real pain to kind of deal with as this thing gets even larger and larger. So what somebody kind of came up with was this idea of like a pipe, right? We call this, there's sort of two ways to write it, and I am sort of a little bit set in my ways. I'm trying, this is like the modern way, but it's this operator of, it's a vertical thing and then a greater than sign. The other way you'll see it is percent sign greater than percent sign, but the idea is the same. And the idea is like, take whatever is here and insert it into as the first parameter of this function. So like this 2 pipe square root is the same as this statement. Put it in there. But then you can take the output of this function and put it into this one, right? So this is sort of saying like, take this thing and put it into that function and down the line, right? So I've taken this statement, which is concise and fits onto one line, but it has the issue of like, I have to count the parens, and I do have to kind of like start in the middle and work my way out, and converts it into this sort of framework where it's like, start with a 2, first take the square root of that, then take the output of that, exponentiate that, and then do a square root finally on all of that. So it does take your code and sort of switch it from read from inside to out to read more from like top to bottom in steps, right? So like, this is kind of a silly example because nobody's ever really gonna write that. But as you know, the way that some of the functions that are really important that we're gonna use work are that they build them very small, and the intention is to kind of like layer them on top of each other and take the output of one and put it into another one. So when you're thinking about in those terms, like this becomes very readable. So like I can, once again, put my cursor here, hit Control Enter, and it'll send all that code into the console and I'll get the same answer. So you'll see this pipe thing. So when you see that, or the other way is percent sign greater than percent sign. That's like the old way of doing it. And I do that sort of naturally. You'll kind of see that. So the pipe is a very like specific R thing.
So how would this be done in Python?
So they don't have a pipe operator. Well, if they do have it's very like unused and nobody does it. So they would write, I mean, you could write it like it's several different assignments. So you could say like, x is equal to the square root of 2, x is equal to the square root of exponentiate x is equal to the square root of x, that type of thing.
Got it.
But then I'm kind of like, I'm not doing it in one statement, I'm kind of doing it.
Seems
in some.
cumbersome.
Yeah. Or they would just write that, you know. But I don't think they really have the pipe. But a lot of the tools are they just work a little bit differently. So like they don't rely as much in R in these, you know, I spoke about the tidyverse. It's sort of these small functions that kind of do one thing, but I add complexity by weaving them together into, you know, several of these things that do, now I'm doing like more complex, meaningful stuff. I think it's a little bit of a different mindset. They don't have that same idea. Okay, so now we're gonna sort of talk a little bit about like exploring like a very simplified version of this workflow. Import, tidy, explore. We'll even do a little teaser model. Okay, so import the data, right? So in my folder, and if you clone this repo, you can get this file as well. I have a data folder that has Apple and SPY price data. Right, so that's where we're using this here function, right? This here package. This is just going to give me like the location of where that thing lives. So this is telling me the relative path. In the lecture 1 folder and the data folder, there lives a CSV file called AAPI. SPY CSV. So if I look at this now, this is actually the location of that file on my computer, right? So like, this part is where my project lives in my drive, and this is where I told it it lives. So within my project, in the Lecture 1 folder, in the data folder, there's this CSV. That helps me like point to where that file lives. And the nice thing about this here folder is that it kind of works on Windows and on Mac. So like on a Mac, you can see I'm using the forward slash. Those would all be backslashes on a Windows machine. So if I had in my code this line of like, this is where this thing lives, that wouldn't work on a Windows machine because you would have to switch all those to backslashes. But if you're using the here package, that's one nice thing that makes it nice, is that like, if I'm on a Windows machine and I run this thing, then it will know that this location needs to all be backslashes. And now I'm going to use another function, and this function is going to read that CSV file for me. So this is going to be pxraw. Now you can see, so this function actually lives in a package that we'll talk about later called reader, but like it's a function for reading data out of different stuff. And it knows how to read CSV, which stands for comma separated values. And it went there and it looked in that file. I told it where to look, and it assigned to a value called pxraw the contents of there. So like, whereas before we were talking about like numbers and vectors of numbers, now this is like true data. This is like a data frame, right? So I have here, well, I can click that thing and see what it is. I can use the str function, right? This is px_raw. We saw that str function. A little less friendly to read. Here's a friendlier function called glimpse that I could use. This is going to kind of show me what's in that data frame. So there's 1,500 rows. This is daily data, 2023, for 5 years. Excuse me. Let me just take a sip. I think it's 5 years. And I have 3 columns: a date, a ticker, and then a value of the adjusted close value of that stock. And that's both Apple, and then the other one's not a stock, it's the S&P 500 index.
Now that is a file that you created just separately, or you downloaded it from somewhere.
Yeah.
And it's now parsing that using
This,
whatever.
yeah, using this read CSV function, right? So it's able to get that and create this type of object, which is a data frame. I could just print that to the. I could just print that to the console to pxraw, right? And it will kind of show me a different sort of way of looking at it. But you can kind of see I've got dates, tickers, and price. So let's do a little bit of tidying. Now, we're gonna cover like what all these functions do, so don't like get too hung up on this, but like here, I'm using a function called mutate, and we're gonna go a lot deeper into what these functions are for operating on my data and how they work. But I'll just tell you that this mutate function is able to take a column and change it in some way, right? So in this case, well, I didn't actually need to do this thing, but because it's already stored as a date, but like this as.date is kind of like ensuring that it's a date. So like, let's say let's say something happened wrong in my read CSV and it read this thing in as a character field. This is gonna make sure that this thing is a date. And similarly, this ticker, it's gonna ensure that it's a character. But what's gonna happen here is like, I wanna change the name of this adjusted close thing to, rather than being adjusted close, I want it to be price. So this is gonna say, create a new column called price. And then later on, we're just gonna select, we're gonna pick out of our data the columns date, ticker, and price. So what's getting kind of thrown out in that operation is this column called adjusted close. And then what arrange does is it just orders my data. So I think a lot of this probably was, might have been unneeded, but like now I'm absolutely sure that like the date's a date, ticker's a character. I don't like the name of this column. I'd rather it be called price, and I can do that. I can do that with that operation. And when I'm done with all of this, this is gonna be ordered by date and ticker. Or actually, I'm sorry, ticker and date. I will put. It'll be organized by date within ticker. You can think of it that way. And you can see that like, I'm using those pipes and I'm sort of composing a more complicated set of instructions from sort of simpler statements. Mutate changes and calculates new changes columns and calculates new columns. Select, picks which columns I want to have, and arrange orders them. So I don't have to do all that in like one function. I put together simpler functions and compose them for more complicated things by using that pipe. So this is going to take all of that output and put it into a thing called PX. So after I ran that, you saw that I put my cursor anywhere in there and hit Control Command Return or Control Enter, and it sent all of that code down to my console. And now I have a new object here called PX, which is a data frame, and I can see that it's got the same number of observations with 3 variables, except now the variables are different because one of them is called price, whereas in this one it was called adjusted close. And here is another sort of useful function, slice head. So this is going to just show me the first 5 rows of my data. And I can inspect it and say like, oh, that's kind of what I wanted it to look like. Okay, so it's kind of a lot, but this is more of a dipping our toes into the water here. And don't worry too much, because we're gonna dig pretty more deeply and more fulsomely into all those functions I just used. So one of the, okay, are we cool? Are we good? Okay. One of the things that you'll kind of see here is that you'll see this word, I use the word data frame quite often, but if I look at what I've created here, it's a data frame, but it also inherits these other objects. You'll see in the, I think you'll see if you read the book, R for Data Science, they use this term Tibble, which is
TBL.
Yeah, which is TBL. And also that guy I was mentioning earlier, Hadley Wickham, who sort of wrote all those functions, mutate and whatnot, he's from New Zealand. So when he says the word table, he says it comes out as Tibble when he says it, like that's how he speaks. So anyways, Tibble, but don't like get too hung up on it. It's just a data frame that's it's slightly friendlier. And the way that it's friendlier is like if I just type PX here, right? It kind of will show me the first 10 rows, and then it'll tell me like there's more rows. If it was just a regular, I mean, if I did data.frame of PX, it prints like all it doesn't stop, essentially.
Mm.
Well, it does stop eventually, but it kind of like essentially spams your console. So this newer sort of object is just a little bit friendlier. It just prints nicely, and it's got a couple other features that are sort of beyond this class's contents. Okay, so we're kind of trying to mimic in a very synthetic and simple way, kind of those steps we were talking about. So we imported the data, we did a bit of cleaning, but we didn't actually look too much at the data. Here, we can explore the data, right? So we can use a package called ggplot. Actually, it's called ggplot2, but this is a great package for plotting, right? So we can create as fancy plots as we can sort of imagine, and yes, to create the plot, right? So I can, oh, that showed up over here. I want this to be over here. And so we can, and we'll get into sort of this syntax, but essentially what we're telling it is, I want on my x-axis, I'll minimize this for now. I want on my x-axis the date, the y-axis the price. I want the lines to be sort of grouped and colored by the ticker. And then I can give it some instructions on how I want these things to look, how wide that line should look. I want to have, I want to get this thing to look nice and pretty, so I want these to be, these represent dollars, so make sure that it looks like dollars. Give me a title, show me my, since everybody kind of gets that this is date, I don't need to have the word date down there, so I can tell it, don't give me any label on my x-axis. But let's label the y-axis price. So in not too many lines of code, I can create a nice plot, and I can, there's all kinds of, you can do all kinds of stuff. You can apply templates, you can do some very interesting stuff with this, the plotting here. But it's a very powerful plotting library, and we'll have a whole sort of segment on plotting and data visualization using R. So that's super helpful. And then we can actually, like now, like let's say we don't really necessarily care about levels of price, but we care about returns. We can calculate new variables in our data, right? So here I can group by ticker. I can create a new column, which is the ratio of price over last day's price, and take that ratio and subtract 1 from it, and I can create a new data frame now that instead of having just 3 variables, has a 4th variable, which is that return, right? So here I can go look at that, and I can see that, like, now here I did have to sort of get rid of NA values, right? So that first day, the 3rd, won't have a return because they don't have the day prior to go look at what my return is. So I did have to kind of get rid of that. But you can see here that I've calculated this new value, and maybe I really care more about this than the level of price.
I'm sorry, step back. You wrote is NA and it accounts for gaps within the dates?
So, yeah, I mean, the idea here is like, if I could get rid of that line, right? And if I just look at the first few rows, I can comment out, right, that line, not a dollar sign, not a number sign. And if I don't do that, the first row, so the way I calculate this thing is I say, like, take the current value, divide it by the previous value, and then subtract 1.
But there's no previous value.
So for
first
this
value.
one, there's no previous value.
Gotcha.
So this first one ends up with that's an NA value. That means like it wasn't able to calculate. It didn't give me like an error when I did the calculation. It just said, it just assigns, I can't calculate this, so I'm gonna not put anything in there. So like, it's still in there, but for purposes of like, maybe no, you know, I don't think anybody really cares about that one. So I can filter it out, I can get rid of that one. Just anyone that has, and I can tell you that there's only gonna be 2 rows in this whole thing that have an NA. It's gonna be the first Apple and then the first SPY down later on. And then here, maybe I wanna do a different visualization on those returns, right? So I'm not gonna go through this, but like we can do, rather than a line graph here, we can do a histogram of the returns, right? So here I'm sort of overlaying on top of each other. These are the SPY returns, and then these are the Apple returns. We kind of can see some come up with some conclusions here. Like they're kind of both centered around 0, right? Maybe a little bit higher than 0. But also it seems like maybe the Apple returns are have a little wider variance than the index returns. And it looks like the index returns might be a little bit tighter. But we can sort of do a little bit more exploration there. And then here, you know, I can summarize this. So rather than doing this visually, I can create like a little table here that shows me I got 752 observations of each of these daily returns. You can see that my mean, as I sort of was saying earlier, is just slightly over 0. And I see a higher standard deviation, a wider sort of spread for the Apple returns as I do the S&P 500 returns. But all of this is sort of facilitated with, you know, just a little bit of code, and you just kind of have to, you know, learn a little bit about the syntax, how all this stuff comes together. And then just real quick, just a little preview here is we can do even a little bit more transformation on our data here, right? So for our modeling purposes, let's say we wanted, what we're gonna do is we're gonna do a simple linear regression of Apple returns on S&P 500 returns. And that's what this line is gonna do. However, the way our data currently looks, it's not really set up, doesn't look the right shape that we need it to. So like if I do PX, or RET is the name of my data frame. You can see here that you know, the problem is I have ticker here as a variable, whereas what I really want is this to be a column name, right? And I want SPY to be another column name. And I want the values in those 2 columns to be my returns. So that's what this does. This is a little bit more transformation that we can do to reshape our data. And we saw select already, so we're only gonna look at date, ticker, and red. We saw filter already. We don't want any of these pesky NA values in there for red, because we know that those sometimes happen. But then this one, pivot wider. If you're familiar with Excel pivot tables, you can do that with this code. And actually, you can do a pivot table. The thing that R can do, and Python can do, that Excel, I haven't seen in Excel, is like an unpivot. You can sort of take columns and make them into more of like a normalized type of a table. So you can both pivot wider, that's the standard pivot in Excel. You can pivot longer, which is like an unpivot, an inverse pivot function, which, like I said, I haven't seen in Excel. So I can create this, and like I said, we're gonna dive deeper into this. So this is merely for like, just to set your eyes on it, but like, you can see that I've created this new table where, you know, it's formatted kind of how I need it to, for my modeling purposes. I need an Apple column, and I need an SPY column. And that's what this little bit of code did for me. And with that, I can run this model. So this is a function that we'll see. This is like a base R function. LM stands for linear model. I'm going to do a simple linear regression, and I'm going to say my Apple returns depend on my SPY returns. So in this case, this is my dependent variable, and this is my independent variable. This is my Y, and this is my X. And I'm telling it that the data I want to use for this, to do this simple model fit, is this thing that I created up here called Y. And I'm going to assign the output of this linear model into this thing called fit, right? So here, and I can do a summary of fit, and we'll talk a little bit about what all this stuff means. But this tells me that I called this linear regression function, sort of regressing Apple returns on SPY returns. This is a summary of my residuals. We're not going to get too deep into all this. This is not like a statistics course, but like this is like statistical output that I would care about. And I'm seeing here that like my intercept is very close to 0. So I don't really care too much about the intercept. That's why I don't care too much about the significance of the intercept. But I do care about the significance here of my SPY stocks, SPY parameter. So here, the way this would sort of look, if I were writing this out as a formula, you know, Apple equals like 0.0001. That's my intercept, plus 1.154 times SPY return. And this variable, this parameter, I'm getting all my words mixed up, but I can look out here at this thing. This is telling me this is statistically significant. So my p-value is very low. So I'm very confident that this thing is not equal to 0, is what that's telling me. And then I can also look through this output at other sort of statistical outputs, and this is the one that kind of, the adjusted R squared and the multiple R squared are what we can look at. So what this is essentially saying is that the SPY return explains 47% of the variance in Apple returns. But this is all like, with one line, I ran this regression and got this, whether this is interesting output or not, it's output nonetheless. So I did some statistical modeling here, and then I can even use that model to do a little scatter plot of my Apple returns to SPY returns, and overlay that regression line that we just estimated. Yeah, we got some outliers. We got an outlier up there. Must have been a really good day. These were some bad days. Okay. Well, okay, so I think there's just a couple of closing slides, and then we'll call it a night. Have you all been doing like the 6:30 to 9:30? Is that like
It's new.
is that new? Okay.
I've done it from my house.
Okay, so I prefer it, I would say. Okay, let's just do this real quick, and then we'll call it a day, because it's getting pretty late. Okay, so I'm gonna do full screen of this. Okay, so this is what we just did. We actually did this part, right? So we loaded data in, we made it so that we could use it, we calculated new variables, right? We changed that adjusted close to price, but then also more meaningfully, we calculated like return data, which is good. We also had to transform this to make it so that the linear model we were gonna run could effectively use the data. We needed to do that pivot there. We did a lot of visualization. We did line graphs, we did histograms, and we did scatter plots. We didn't really iterate too much. We created one model. And then we did do some summary data to help us with communication. So part of the assignment is to check out this chapter 1 of ISL, Introduction to Statistical Learning. And then that's a non-sort of technical chapter. It's about how we talk about models and not how we compute them. And we'll use this vocabulary all semester. You know, we'll kind of get to this, like, I don't wanna talk too deeply about this stuff, but statistical learning, this is all covered in chapter 1. Prediction versus inference, we didn't really talk about that too much, but there's kind of 2 reasons why you would build a model. Either I'm trying to predict something, or I'm trying to understand how something affects something else. Those are quite different. We do talk about training versus test performance. This is going to be a huge component of when we start talking about evaluating models and comparing models. Overfitting is a word that we'll use. You'll get tired of me saying it, but you're always worried about overfitting. And we are always discussing trade-offs when we're talking about models. And then I just wanted to do a little bit of overview about, like, so in the syllabus, you'll see a link to the class Git repository that has all the slides. I'll put a lot of this stuff in the Husky CT, but I think that more stuff will probably end up in the Git repo. So, like, for instance, that Apple SPY data is in the Git repo. I don't think it's in Husky CT. But if you want to get this stuff, there's kind of 2 ways to go about it. You'll sort of, when you open up, when you see it in Git, you can click on this code button. You'll see it's going to be kind of on the upper right-hand side. And you can download a zip file that has all of the contents of everything that's in that repository. This is a little inefficient because, you know, if I want to go back next week and get it, I'll download all of it again, but it works. The other thing you could do is, like, you could actually clone the repository. We're not going to get too involved with that, but if you wanted to sort of do a little ChatGPTing or Googling about it, it actually makes it a little bit easier. Like, you know, I've got my project in R set to sort of point to the repository. So if I were doing this, I could clone it in kind of like a 1-step thing, but it is a bit more complicated. So if you really want to investigate that, you could sort of do, like I said, Google, ChatGPT. This there's a reference to this thing, Happy Git with R, that kind of walks you through it. Or if you really wanted to, I can help you out too. You can just reach out to me. And for tomorrow, like, check out sections 1 through 8 in R4DS and ISL R chapter 1. And I think that's it. I think we did it. Good first class, everybody. Nice meeting you all. And we'll come back next week. Thanks, everyone. Whew. All right. That takes a lot out of it.
Teaching?
Yeah.
Okay.
Yeah. It's hard to talk. You heard my voice.
How do you, if it's hard for you to teach, how do you think it is for us to learn?
I don't envy you. Having to listen to me for that for 3 hours. All right, so yeah, next week we'll do a little bit more in depth on primarily graphing and some of the stuff around we were seeing there, like filter, select, mutates is kind of the next step next week. All right.
Those problems start next week?
What's that?
There's problems in the syllabus, those are,
Yeah, I mean, yeah,
are we turning them in?
yeah,
And if so, how do you want them? Electronically?
yeah, electronic. Normally we have a TA, I don't think we've yet gotten a TA, so, yeah, if you were to email me those to me, that'd be great.
You just what, raw R files or like an R markdown into an HTML or?
I mean, I think these ones you could do R Markdown, you could do that, or you could sort of, I've seen people sort of more do it like a Word document where they're pasting output into there and that type of thing, so however is most convenient for you. I'm not too discerning, it's like.
But on this, are you assigning these on the 27th or to be turned in on the 27th? Like you have,
So those are actually,
For next
nothing's
week?
gonna be due next week.
Okay.
Those are due, that's when.
That's the assignment date.
When it is assigned, yeah. Yeah, so nothing is due next week.
did you ever see this book?
Which one?
The time series one?
Who's the author? Oh, yeah. I think I saw a talk by that guy, Heinemann.
The guys from our book also have all their lectures on YouTube too.
Okay, yeah,
So if you look for it, you'll find them.
cool. Have you used that book? Or you
Yeah, I've
just-
seen this book. Yeah, we used this book for a forecasting class I did in New Haven.
Cool. And was it an R?
Yeah,
That guy Heinemann, I think, is an R guy.
yep. He actually wrote his own library. FPP3 is the current version of it.
Okay. Is he one of those, is he like a Facebook guy? Cause I know those Facebook came out with like a big, forecasting package.
Well, they have their own, Facebook made their own, they call Prophet.
Profit, yeah. He's not that guy. is he?
No. This guy uses Sybils.
Okay.
Tibble with the S behind it for the time
Oh,
series.
Yeah, T.S. Sybil.
Yeah.
Sybil.
Do you have office hours listed?
Well, I have a day job. So, like, if you reach out to me, we can
I fancy myself as a smart individual, I just want to make sure that
Yeah. You'll get there.
I'm hoping. I'm an accounting and finance guy, not a computer science guy. I think that's my cousin who also went to Columbia. He was a compy guy. Yeah. Nice to meet you. So,
Okay.
We're done?
oh,
I'll see you next week.
riveting, and I mean that honestly, because this is a world that I've not ventured in. Like I was telling the other guys, I'm a VBA guy, like
Oh,
Visual
okay.
Basic, that's where I come from. This is new uncharted water.
There's definitely like parallelism, like there's. I tend to stay away from it.
Well, because
And also, I don't like to tell anybody. I don't receive any questions.
gotcha.
All right, see you next week.
Have a good night.
Later.